Crystal lattices and unit cells. Consider a crystal. We know that the main characteristic of crystalline solids is its regular and repeating pattern of constituent particles. Now, when we replace these particles with representative points, a crystal lattice is obtained. Crystal lattice is defined as the three-dimensional arrangement of constituent particles, represented diagrammatically such that each particle is depicted as a point. Such an arrangement is known as crystal lattice. There are 14 possible three-dimensional lattices known to us. These lattices are named after the French mathematician who first discovered it. Thus, they are known as Bravais lattices. In addition to simple lattices for other systems, it is observed that there are 14 different types of space lattices. These are known as 14 Bravais lattices. These lattices were given name after a French mathematician who first described them. Now we know what is a crystal lattice. Let us study some of its characteristics. Each point in a crystal lattice is called lattice point or lattice site. Each point in a crystal lattice represents one constituent particle, which may be an atom, a molecule, or an ion. Lattices points are joined together by straight lines to bring out the geometry of a crystal lattice. Now, if we observe this crystal lattice, we can notice that there is a small group of lattice points that repeats itself again and again to form an entire crystal lattice. This small group of lattice points is known as unit cell. Thus, unit cell is the smallest portion of a crystal lattice. When repeated in different directions, generates the entire lattice. A unit cell is represented by three edges A, B, and C, represented along X, Y, and Z axis of a three-dimensional entity. And these edges may or may not be mutually perpendicular to each other. When these edges join, they form certain angles. They are represented as alpha, beta, and gamma. The angle between edges B and C is alpha. The angle between A and C is beta. And the angle between A and B is gamma. Thus, a unit cell is characterized by 6 parameters: A, B, C, alpha, beta, and gamma.